GX 2012's sturdy, high-impact plastic case is radio frequency RF resistant and is suitable for use in many environmental conditions indoors and out. The case is dustproof and weather resistant. A rubber layer on the outside of the case protects it from scratches and impact damage. A clear plastic window through which the LCD can be viewed is located on the front of the case. 4 brass charging contacts that are used when the GX 2012 is placed in the charging station are on the back of the case. Both the rechargeable and alkaline versions include a removable battery pack. The battery pack release latch is on the bottom of the instrument. The alkaline battery version also includes a battery cover release knob. The battery pack and flow chamber are located on the back of the GX 2012. The inlet filter holder is located on the top of the GX 2012 case. The GX 2012 uses up to 5 sensors to monitor combustible gas, oxygen, carbon monoxide, and hydrogen sulfide simultaneously. The sensors are located inside the GX 2012 and are held in sockets by the flow chamber. There is an infrared communication port located just below the reset silence button, which is used to transfer information when the instrument is used with one of the calibration stations or downloading accessories. The belt clip is used to easily clip the GX 2012 on a belt. There are 3 threaded inserts on the back of the case. These are used to mount the belt clip. 2 of the inserts are also for the flow chamber. A cone-shaped 4-inch long rubber nozzle is included with the GX 2012 as standard. It can be installed on the inlet fitting by pushing the larger end over it. The smaller end can be inserted through a hole in a wall or some other access to an enclosed area to sample the environment. A 10-foot sample hose and a 10-inch probe are included as standard with the GX 2012. When desired, the rubber nozzle may be removed and the sample hose and 10-inch probe may be connected to the inlet fitting. Sample hose lengths are available from 2 to 50 feet. The quick connect end of the sample hose connects to the inlet fitting of the GX 2012, and the probe screws onto the end of the hose with a threaded fitting. An optional bar hole probe is available for the GX 2012. It is designed to be used when the GX 2012 is operated in bar hole mode to check bar holes when tracking down underground gas pipe leaks. The bar hole probe has the same handle as the standard probe, but has a 30-inch fiberglass tube instead of the standard tube. 4 holes are drilled through the 30-inch tube's wall near the end, and the end is plugged so that debris from the bar hole cannot be drawn into the tube. The sample is drawn through the drilled holes in the tube wall. The sensor gasket seats onto the sensors and seals the interface between the sensors and the flow chamber. The flow chamber sits on top of the sensor retainer. 3 screws secure the flow chamber to the case. The charcoal filter disc is located in a recess in the sensor gasket just above the CO sensor. It is black, has a woven texture, and is impregnated with a hydrogen sulfide absorbing material. It fits into a recessed area of that port. The CO sensor will respond if exposed to hydrogen sulfide and certain hydrocarbon gases. The charcoal filter scrubs these gases out of the gas sampled to avoid false CO readings. The H2S absorbing material added to the charcoal filter extends its H2S absorbing life. If false CO readings are noticed, especially high readings in the presence of H2S, change the charcoal filter disc. One H2S removal filter disc is located in a recess in the sensor gasket above the LEL sensor. The H2S removal filter disc is white when new. It scrubs hydrogen sulfide out of the gas sampled to increase the life of the combustible sensor. It darkens as it absorbs H2S and must be changed when it turns to a dark brown color. The recommended replacement frequency will depend on how often the unit is exposed to H2S and the concentration. Check the condition of the H2S removal filter disc quarterly. The GX 2012 uses up to 5 sensors to monitor combustibles, oxygen, carbon monoxide, and hydrogen sulfide simultaneously. The combustible gas sensor detects combustible gas and vapors in the lower explosive limit range, or LEL, with a catalytic element. A sintered metal flame arrestor covers the element and allows ambient air to diffuse into the sensor. The reaction of gas with oxygen on the catalyst causes a change in the resistance of the element, which affects the current flowing through it. The current is amplified by the GX 2012's circuitry, converted to a measurement of combustible gas concentration, and displayed on the LCD. The percent volume combustible gas sensor detects methane in the percent volume range with a thermal conductivity element. It is not always installed in the GX 2012. The reaction of gas with the sensor cools the active element and causes a change in the resistance of the element, which affects the current flowing through it. The current is amplified by the GX 2012's circuitry, converted to a measurement of combustible gas concentration, and displayed on the LCD. The oxygen sensor is a galvanic type sensor. A membrane covers the cell and allows gas to diffuse into the cell at a rate proportional to the partial pressure of oxygen. The oxygen reacts in the cell and produces a voltage proportional to the concentration of oxygen. The voltage is measured by the GX 2012 circuitry, converted to a measurement of gas concentration, and displayed on the LCD display. The CO and H2S sensors are electrochemical sensors that consist of 2 precious metal electrodes in an acid electrolyte. A gas-permeable membrane covers the sensor face and allows gas to diffuse into the electrolyte. The gas reacts in the sensor and produces a current proportional to the concentration of the target gas. The current is amplified by the GX 2012 circuitry, converted to a measurement of gas concentration, and displayed on the LCD. The GX 2012's liquid crystal display during normal operating mode will show the current gas readings for all gas channels, battery conditions, and any alarm indications. When a control button is pressed, the LCD backlight comes on for 30 seconds. 5 control buttons are located below the LCD. They are arranged around a central button, the power enter button. The primary function of the GX 2012's printed circuit boards are to amplify the signal sent to them from the gas sensors, convert the signal to a measurement of gas concentration, display the gas concentration on the LCD, store peak, STEL, and TWA readings, and activate the alarm circuit if an alarm point has been reached. The circuit board also monitors battery level, battery failure, and sensor failure. They also control the GX 2012's time function and various operating modes. There are bright red alarm LED lights located on 3 sides of the instrument to increase visibility of alarm conditions. An internal solid-state buzzer is amplified through an audible alarm port located on the top front of the instrument and provides a 95 decibel alarm. The buzzer will sound for gas alarms, failure alarms, and as an indicator during normal use in various operating modes. An internal vibrating motor will vibrate for gas alarms and as an indicator during normal use in various operating modes. A lithium-ion battery pack supplies 3.7 volts to power the GX 2012. The batteries will run the unit for up to 10 hours when no alarms have been activated during that time period. The battery pack may be charged in or out of the instrument using the GX 2012 charging station. The battery icon in the upper right corner of the LCD shows the charge remaining in the batteries. An alkaline battery pack can also supply the 3.7 volts needed to power the GX 2012. The batteries will run the unit for up to 15 hours when no alarms have been activated during that time period. The batteries in the pack can be replaced. The battery icon in the upper right of the LCD shows the charge remaining in the batteries. The GX 2012's lithium-ion battery pack is charged with a GX 2012 charging station. There are two types of charging stations available: the standard AC-powered charging station and the optional vehicle plug DC-powered charging station. The single instrument charging station consists of one instrument charging base and an AC adapter. The AC adapter for the standard charging station plugs into a 115 VAC wall outlet and connects to the charging station with a jack on the end of a 5-foot DC output cable. The AC adapter will also work for 100 VAC or 220 VAC if an appropriate plug adapter is provided. An optional DC-powered single-instrument charging station is available with a 12-volt DC vehicle plug. It uses the same charging base as the AC-powered charging station, but comes with a Velcro strap to secure the GX 2012.